Today on Untitled, I'm happy to bring you the internet's most simple maglev circuit. In this video, I'll be showing you how to make one of these mini desktop toys for yourself. And you can see I have a very small paper crane mounted on these two magnets. A fascinating thing to watch with these mini maglevs is the procession of gyroscopics if you get the magnet spinning fast enough. And here, I'll be blowing on the magnet from the side just to get it spinning. After a while, the magnetic field interactions between the magnet and the electromagnetic coil start to create some really weird spinning effects. About right here where the magnet starts to drift off its rotational axes. Watch closely and see what happens.
Let's check out some options. So here we have an Arduino based option for magnetic levitation, and I have pretty much all of these parts. I even have the Arduino. The problem is I have no idea how to use this. I'm an analog guy. So let's look at a analog schematic. Okay, well that's a little bit more my native language. Now I'm going to do a little bit of programming on this whole block here, because let's face it, as I said, that's what I know. So even I think this is a little too complicated. So let's see if we can make this a little simpler.
Alright, first the importance. We need an N-channel Mosfet, and whatever the FET will work. We're going to need an electromagnetic coil. Then we're going to start drawing our power terminals, getting rid of parts we don't need, wiring up our sensor, getting our two resistors that we need for the Mosfet control hooked up to the gate, and some other wiring done, and we'll be good to go. Perfect. So here it is, the finished circuit. After a few minutes in Illustrator, it looks much nicer and much easier to follow. If you're making your own electromagnetic coil, this is the way you want to wrap it and how you want to connect power for this circuit. I won't be making my own electromagnetic coil for this project. Instead, I'll be using one of these double coil assemblies pulled from a 5-volt stepper. This motor came from the floppy drive read-write head assembly. Also, you'll have to put a piece of metal in the center of your electromagnetic coil, otherwise it won't work as well. So first I'll begin by taking a small piece of wire and wiring these two coils in series, following the same direction as the wiring diagram before. A little bit of inspection and you can see that the coils are assembled correctly. Another thing you can do at this point is to mark the 2 pins left over for positive and negative. Now it's time to prepare your resistors. Twist your two resistors together. In this case, I'm using a 400 ohm and a 2.2 kilo ohm resistor. After that, solder them and clip off the extra, leaving enough to attach your Mosfet. I'll be wrapping the resistors around my electromagnetic coil for positioning and preparing to put my Mosfet in place. I'll be using an SO8 form factor Mosfet, which is a surface mount type. The gate of the Mosfet will have to touch where the two resistors meet in the middle. So I'll be locating pin 4 on this Mosfet, bending pin 4 down so it reaches the resistors easier, and then preparing to solder it in place. If you're curious on where to find these types of Mosfets, they're actually really easy to locate in most laptop motherboards, in things like vape mod boxes, and other small electronic devices that use a lot of power. So see if you can find some on your own, and look up those part data sheets online. If you're following along on this project, I want to include a lot of really up-close video shoots of the entire project like this, so that way you can see exactly how everything is connected. It's time for some negative input wires now. You'll need a small length of very thin wire for your sensor, and you'll need a much longer length of wire for your main negative power in. After twisting those wires together, solder them together and clip off the remaining extra. Both these wires you'll now be soldering to your Mosfet source. And here's another close-up view of the project. I have my Mosfet actually upside down at this point, and I've already connected up all the negative wires to my source of the Mosfet. I have a 470 ohm resistor to the right and a 2.2 kilo ohm resistor to the left. Now it's time to prepare a small length of wire, anywhere from 2 to 3 inches. This will be soldered to your Mosfet drain. In this case, because I'm using an SO8 form factor, I'll be soldering on these 4 pins, which are pins 5 through 8. It might look a little bit busy when it's on the coil, but really, there's not much to this. So far, only 2 resistors and 3 wires have been attached to our Mosfet. Really simple, right? At this point, just for durability, we can now glue this onto our electromagnetic coil. Before gluing your Mosfet and 2 resistors down, tuck your additional extra wires against your electromagnetic coil, therefore ensuring plenty of room for the wiring that goes to your Hall effect sensor and the additional LEDs that you can choose to install. Now it's time to connect your Hall effect sensor. Take the black wire coming from your Mosfet source and connect it to the center pin of your Hall effect sensor. After that, prepare red wire and connect it to the left pin of your Hall effect sensor. After that is done, you'll be connecting a blue wire to the right pin. I'm using an AH543 Hall effect sensor, but if you know a better Hall effect sensor, please let me know. The red wire will be connecting to your 5 volt positive, and the blue wire will be connecting to your 470 ohm resistor. You can't have the negative without the positive, so now we'll be preparing the positive inputs. We'll be taking a longer length of wire and connecting it to the smaller length of red wire coming off the Hall effect sensor. With these connected together, you can now attach them to the positive input of your electromagnetic coil. Here's another close-up view on those connections. Just a few more vital connections to go. Locate the wire that comes off your Mosfet drain and connect it to the negative terminal of your electromagnetic coil. Once the Mosfet is fully connected to the negative of your coil, locate the positive connection of your coil and solder on your higher value resistor, in my case, the 2.2 kilo ohm resistor. And now it's time to make the last connection of your electromagnetic circuit, which is to connect your sensor output to the 470 ohm resistor. To test this circuit, I have connected up a blue LED in parallel to my electromagnetic coil assembly. As you can see, the LED comes on as soon as I connect power, in this case, a 3.7 volt lithium-ion battery. If you've chosen to test the circuit the same way I have, you'll notice the LED stays lit until the magnet is put close to the Hall effect sensor. This is how your circuit should be working. After completing your circuit, glue your Hall effect sensor on a small disc of plastic anywhere from 1 millimeter to 3 millimeters thick. 1 millimeter seems to be the best. Make sure it is centered as possible, and now you can test out your system. So now that you hopefully have a circuit working, just some things to note during setup. This is a 3.5 to 5 volt circuit. Putting any more than 5 volts into the circuit may damage your Hall effect sensor. Another thing to note is during tuning, you might need to do things like change the distance between the Hall effect sensor and your electromagnet. Another thing you can try to tune this circuit is to place another magnet on the top of your electromagnetic circuit. Doing simple things like this can greatly improve the results of your own project at home. Now that I know that my electromagnetic coil assembly works the way I want it to, I'll be unsoldering some of the longer sections of wire and then cutting them to length and resoldering them back in place. This just gets rid of some of the extra wire in the assembly and makes the entire assembly look a whole lot neater. Plus, it helps for installing things like LEDs and putting on a neat cover cap to hide all the electronics and wires. If all this rewiring seems a little confusing to you, don't worry. I've taken the time out to make 2 illustrator diagrams for you. Here's the side of the assembly that has a Mosfet connected to the 2 resistors, as well as the wiring for power. And here on the other side, the wiring for the 2 resistors going to the Hall effect sensor and other power connections to the electromagnetic coil. Well, I have to say, this for expectations versus reality. It sure isn't pretty, but unlike the illustrations, at least it works. Now to make a base, you're going to need some plastic, a sharp tool, something to put on the plastic, measure your lines, drag your sharp tool across the plastic, find a good edge to work on, and place the score mark along the edge and press firmly. It's that easy. After cutting out your desired shape of plastic, use a heat gun torch or other source of heat to get the plastic warm, and that way you can bend it around to the shape you want it in. After applying the first bend to the bottom, heat up the top section, so that way you can make another parallel flat top for the electromagnetic portion to sit on. And there you have it, a nice easy base. Once you have your plastic base completed, make a hole in the top if you're going to screw your electromagnetic assembly to it. Otherwise, you can just glue your electromagnetic assembly to the top and it will work just fine. If you are gluing on your electromagnetic assembly, I would recommend using super glue or another fairly high temperature glue, as the coil may get too hot for hot glue. I've also chosen to include LEDs on my little magnetic levitator, and here I have 2 LEDs that I pulled from a cell phone connected to a 470 ohm resistor. With 5 volts, they work pretty well. You can use pretty much any small LED you would like, and all you'd have to do is glue them around the outside area of where your Hall effect sensor is. So here I'm using super glue to glue down my 2 LEDs, and here they are on the side. The blue wire is actually my positive, which is connected to the 470 ohm resistor and then to my electromagnetic coil's positive. The white wire coming off my LEDs is my LED negative and goes to my negative on my electromagnetic coil. Once the LEDs are installed, you can now test them. You can use almost any small plastic cap for your electromagnetic coil cover. Here I'm using a vape juice bottle cap for mine, and it works pretty well. A little bit of hot glue and it's in place. The second to the last step in this project is to put a small hole in the back bottom side of your base to run the power wires through. And once the power wires are run through the hole, use glue or tape to secure them along the back side of your base. And now for the last step, and my very favorite step, to take this plain old boring magnet out and replace it with something a little bit more artistic, in which case, this little plastic airplane that I made to float in my new magnetic levitator. If you enjoyed this video, give it a like and subscribe to my channel for more DIY videos like this. And one of the upcoming projects will be how to put this all into an e-hookah. Until then, you know what to do. Stay tuned and have a good day.